Hello everybody, our lesson today is irrational number. We have first rational numbers. We studied it in grade 7, and in our year we will study irrational number. How do I differentiate between rational and irrational numbers? First, we know natural numbers like 0, 1, 2, 3 and so on, and integers 0, 1, 2, 3 and -1, -2, -3 and so on, and irrational number from grade 7 like 0.4, 0.3333. What's the meaning of this dash? This dash, it means 3 and 3 and 3 and so on. If we write it in our calculator, it will be 1 or 3. Okay, and mixed number is rational number. -3/7 is rational number. Any number we can put in the form a/b, it will be rational number, and b doesn't equal 0. Like -4 is rational. Why? Because we can put 1 under -4. So any number in the form a/b, it will be rational number, and the denominator not equal 0. In the other side, the irrational number. Irrational number like √5. √5 hasn't got a perfect square, so √5 is √5. And number like this, √3 + 1 is irrational number. And √0.5 is rational number. Pi is irrational number. Mr. Pi has approximated value. Yes, I know. You said approximated value, like 22/7 and 3.14. This was an approximated value for pi, and this was approximated value for pi. Doesn't equal the exactly value of pi. Pi is irrational number. And like what? Cube root of 3, cube root of 5, and so on. These are irrational number. A fraction with a denominator of 0 is undefined because you cannot define by 0. So it is not a number at all. You can try it on your calculator. Write 5/0. It will give us math error because the denominator is 0. Check your understand. State whether each of the following are rational or irrational. √6, we cannot find √6, so √6 is irrational number. √25 equal 5. 5 is rational or irrational? Very good, rational number. √27, check in your calculator, it will be irrational number. √3, irrational number. Simplify √32 over √8 first. It will give us 2, so 2 is rational number. Simplify √244 over √11, so it will be rational number. Simplify first √18 over √2, it will be rational number, and so on. √25 equal √5, so it will be irrational number. In decimal form, 0.73, is it terminating decimal or recurring decimal? It's terminating, therefore 0.73 is rational number. √2, irrational. 0.6666, it will be in final equal 2 out of 3. 2 out of 3, it means rational number. 3.142, only these numbers, it will be rational number. √12.25 is irrational. √7 irrational. √5 plus 4 equal hasn't got any answer, it will be irrational number. Simplify this first, it will be 3. So irrational number, it will be irrational number. Root 16 power half, and we will get it in the other lessons. Cube root of 2 power 2, check in your calculator, it will be irrational number. Find an approximated value for each of the following numbers. Root 11 to the nearest hundredth. To the nearest hundredth, it means we need only 2 decimal number after decimal point. If we write root 11 and press SD in your calculator, it will be 3.32. Cube root of 7 to the nearest tenth, it means 1 decimal point, it means 1.9, and cube root of negative 9 to the nearest tenth, it will be negative 2, because it's negative 1.8 and so on. In this example, we need 2 integers that root of 5 lies between them. We put what? 5 first, and bigger than and less than. 5. The number in perfect before 5 is 4, and after 5 is 9. You need 5 or root 5? Root 5. Take the root for all sides. So it will be 2 here and 3, and the answer will be 2 and 3. Root 12. Root 12. We put 12 like this, and bigger than and less than. Number before 12 but in perfect square like 9. After 12, 16. Take the root for all sides. It will be 3 and 4. Negative cube root of 20. We put negative 20 here, and we need a number less than negative 20 in perfect square like negative 27, and a number bigger than negative 20 in perfect cube like negative 8. We need negative 20 or cube root of negative 20, negative cube root of 20, then we take cube root for all sides. Negative cube root of 27, it will be negative 3, and here is negative 2. So negative cube root of 20 lies between negative 3 and negative 2. Very good. The same, he need x, and root 2 lies between 2 integers. So we do like the previous example. 2, put 2 bigger than and less than, 2 bigger than 1 and less than 4 in perfect square. So we take the root for all sides. It will be 1 and 2. Then we put 1 here. So x it will be equal 1. Very good. The second example for you. Put it 20, put 80 here. The perfect before 20, 80, and after 80. After 80 it was 81, and before 80 it was 64. Take the root for all sides. It will be root root, and root 64 was 8 and 9, so the number was 8. Prove that root 2 is included between 1.4 and 1.2. It's too easy. First, we put root 2 in decimal form. It will be root 2 equal 1.41. 1.41 bigger than 1.4 and less than 1.5. So we take this for what? For root 2. Therefore, root 2 replaced it. Root 2 bigger than 1.4 and 1.5. We put 1.41 bigger than 1.4 and 1.5, and so on. Solve the equation in Q dash. X power C equals 7. We need X, not X power C. Since X power C equals 7, therefore X equal cube root of 7. Cube root of 7 lies in Q dash, yes, therefore solution set equal Q, and Q dash is cube root of 7. In this example, we take 2 in the other side by the opposite sign and negative 27 plus 2. So 64 x power c equal negative 27. We need x alone, then we take 64 here by divide, very good. So x power c equal negative 27, and finally we need x not x power c, therefore x equal cube root of negative 27 over 64, and x equal negative c over 4. Negative c over 4 included in q dash? No, therefore solution set it will be 5. Very good. Another example, find the length of diagonal of a square whose area is equal 5. Area equal 5. First step, let the side length of the square will be L. The area of a square was L power 2. It means side times side. And L power 2 is the rule of area. And we have 5 in area of square, therefore L power 2 equal 5, and to get L only we put the root in the other side, therefore side length of square equal root of 5. Draw the square like this, A, B, C, D, and its diagonal AC, and put what you get, root of 5 here and here, and this angle is right angle. Don't forget Pythagoras theorem. To get AC, the diagonal AC, we do what? Since in triangle ABC is right angle triangle at B, and the rule of theorem Pythagoras, AC power 2 equal AP power 2 plus BC power 2, and we replaced AB and both root of 5, BC and root of 5. Power 2, it will be 10. Therefore, AC equal root 10, and the diagonal is root 10. Thanks.